Year 9. This is our fourth video on direct proportion. So this video is based on my lesson 4 notes, but there will be two videos on this. First video will be only on linear relations and direct proportion. Okay, so let me make it clear. A linear relation is a relationship you see that's the graph of x and y, you see a straight line. But we have learned that for a direct proportion, it's also a straight line. So what's the difference? Okay, let me show you three graphs. What's the difference of them? Okay, so the first graph, you see that's a straight line, but it does not pass through the origin. Okay, the second straight line, it passes through the origin, and also just like the first one, the straight line rises, so what we call a positive slope. For the third one, the straight line actually decline, and it does not pass through origin as well. Okay, so when we have three straight lines, all of them are called linear graph. All are called linear graph, or we just say them, they are linear. Okay, a linear relation between x and y can always be represented by a straight line. So whenever you see a straight line, this is showing a linear relationship. But only the middle one, the one that's a straight line which rises and also passes through the origin, is a direct proportion. So that means a linear relation does not necessarily mean a direct proportion, but a direct proportion must be a linear relation. So that's the summary. Note that a direct proportion is a linear relation, but a linear relation is not necessarily a direct proportion. Keep that in mind. So we're going to the next part. So let's make some comparisons between a linear relation and a direct proportion. First of all, let's see, is linear relation a straight line graph? Yes. It must be, right? Is a direct proportion a straight line graph? Yes. Does a linear relation must pass through the origin? Not necessarily. It might be, but not necessarily. Okay. Not necessarily. A direct proportion, it must pass through origin. Double line method. Still remember double line method? That means if one quantity is increased by 5 times, for example, then the other quantity must be increased by 5 times as well. So for direct proportion, yes. But for linear relation, not necessarily. The graph rises for direct proportion, yes. For linear relation, not necessarily. We see one linear relation, actually the line declines rather than rises. Constant slope. Constant slope means it must be a straight line to have a constant slope. Okay? So actually we are going to use the idea of slope as the change in y versus change in x, but we are going to that into more details later on. For constant slope, that means you see a straight line. Linear relation, yes. Direct proportion, yes. So you see there are lots of things which happens to a direct proportion only, but not necessarily to a linear relation. So that means we need to be careful. So the first example is about a little bit revision. Let's check if the following pattern is showing a direct proportion. Okay, I give you this example because later on we will have a similar tables, but for that time we are going to use different approach to check whether the relation is a linear one. But before that, let us consolidate a little bit we have learned from the double line method. Okay, you must use double line method to check if the pattern is a direct proportion. Still remember the double line method? For example, if from 1 to 2, it times 2. From 2 to 4, does it times 2? Yes, 2 times 2 is 4. Okay, from 2 to 3, it times what? Times 3 over 2 or 1.5. Okay, from 4 to 6, it times 6 over 4. Is 6 over 4 equals 3 over 2? If you do a little bit simplification, you see they are equal. So that's why that means from the second number to the third number, we still keep the ratios the same. Alright? Okay, the last one from 3 to 4, if you times 4 over 3, does it happen to that 6 to 8? From 6 to 8, we times 8 over 6. But 8 over 6, when you simplify them, actually they are also 4 over 3. Okay. So that basically means whatever factors it puts on on x, the same number you should multiply on y as well. Okay. So this means this showing a direct proportion. X and y are in direct proportion. Or you might say varies directly. Okay. Let's move on to the next question. Oh, let's see this one. From 1 to 2, you times 2. From 3 to 5, you need to times 5 over 3. But of course, 5 over 3 does not equal to 2, right? So, we understand x and y are not in direct proportion. Not in direct proportion. Okay, let's move on to C. Let's have a look. Times 2. Okay, 10 to 20. You times 2. It seems good. 4 to 6, you times 6 over 4 or 1.5. 20 to 30, you times 30 over 20. So when you simplify, it's also 1.5. Okay, so let's check the last one. So when you times 8 over 6, is actually 4 over 3, or if you use calculator 1.3 recurring decimal. And okay, so if you use calculator, it's recurring decimal 1.3. Alright, so that means we are always having the same factors to multiply x and y. Okay, therefore we say x and y are in direct proportion. Okay, sorry. Okay, some of you might see in B, I just track the first pair from first pair to the second pair, I didn't track the rest of the numbers, and I say they are not in direct proportion. But for question A and question C, I need to track all those pairs. Why I did like this? This is because when you are trying to see something is in direct proportion, you have to track all of them to prove that they are in direct proportion. But if you got one pair showing that they are not in direct proportion, then it's already sufficient. Even the rest of them showing the pattern that they are multiplying the same factor. But you've got one pair which is not using the same factor to multiply, then that's it. Okay, so to disprove something as a direct proportion, actually it's easier to prove something is a direct proportion. Alright? So for the last one, let's track. Okay, 3 to 5, that's times 5 over 3. 8 to 14 times 14 over 8. But 14 over 8 is like, okay, when you simplify it, it's 7 over 4. So 5 over 3 is not 7 over 4. Therefore, we say x and y are not in direct proportion. Okay, so basically in example 2, we see two questions which are in direct proportion, the rest and the other two are not. Example 1, there's nothing new. We are using just a double line method to check whether these numbers follows the pattern for a direct proportion. But then I'm going to show you how to check whether a relation is a direct, whether a relation is a linear relation. Okay, to track whether it's a linear relation, we're not going to use multiplication, we're going to use plus. Okay, for example, if you see our first part A, so for this A, 1, 2, 3, 4, y is 2, 4, 6, 8. We remember this is a direct proportion. Okay? Now, for this one, I'm not going to check whether this is a direct proportion. Of course it is, but we are not going to check that whether they are direct proportion. We're going to check whether this is just a linear relation. Okay, to see whether this is a linear relation, let's see. You use plus, you try to look for the change in x. Okay, the change in x. And then the change in y. How could we see the change in x, not just x? Okay, from 1 to 2, so 1 plus 1 is 2, so it's plus 1. So that's change in x is plus 1. And change in y from 2 to 4 is 2. So from first pair of numbers to second pair, okay, x is increased by 1, y is increased by 2. So how about delta y over delta x? We are going to see the ratio between the change in y and change in x. So you will see 2 divided by 1. So that's the ratio. And then we move on to second pair to the third pair. And you will see from 4 to 6 is plus 2. From 2 to 3 is plus 1. Alright? So this time, delta y over delta x, okay, that's the pronunciation. Delta y and delta x, that means the change in y and change in x. So for convenience, I'm going to just say delta y and delta x. And delta y over delta x is 2 over 1. And the last pair, from the third pair to last pair, you still see that's 2 over 1. So see, delta y over delta x, they always equal, right? They always equal. So that's why that linear relation. So for a linear relation, you should see that's delta y over delta x as a constant. Okay, then you will have, if you have such a pattern, then this is a linear relation. Alright, unlike it's not necessarily a direct proportion, but it's linear. Okay, of course, if you want to check whether they are also a direct proportion, then you need to use the double line method we've shown you before. Alright, let's move on to another one. So for this one, x from 3 to 5 increased by 2, y at the same time from 8 to 14 increase by 6. Okay, so delta y of delta x 6 over 2, and from 5 to 7 increased by 2, 14 to 20 increased by 6, again 6 over 2. So again, they always equal. So that's why this is also linear. But be careful, this is not in direct proportion. If you try to see from the multiplication perspective, you will see when 3 go to 5, 3 times 5 over 3, but from 8 to 14, it times 14 over 8. And two factors are actually they're not equal, which we have shown in the above examples. So remember, so this one is not a direct proportion, but it's still a linear relation. Remember that a linear relation, a direct proportion must be a linear relation, but not necessarily a linear relation must be a direct proportion. It's wrong, right? Okay, let's have the last one. Okay, so this one you see 2, 4, 8, 6, 8. So each time delta x plus 2, but when you look at the delta y, so delta y from 12, 20, 28. So you see actually when you use delta y over delta x, you see they are different. They're different, right? 12 divided by 2 is actually 6, but 20 divided by 2 is 10. So they're not equal. They're not equal. So this is not a linear relation. Alright, so that's the way we try to figure out whether a pattern given is a linear relation. It's different to the way we check whether a relation is in a direct proportion. Okay, let's have some exercise. Examine whether the following relation is linear. Okay, so you need to read the question very carefully. For the same type of question, it might be asking you to check whether they are direct proportion, or whether it might be for you to check whether they are linear. Okay, so you need to see the question carefully. If they are asking you to check whether relation is linear, what kind of method are we going to use? Are we going to use double line method? No, you are going to use whether delta y, delta x is or not a constant. Okay, that's what you have to do. Okay, so for x is 1, 2, 3, 4. For y, 4, 8, 12, 16. Okay, let's see. From 1 to 2, it plus 1. From 4 to 8, it plus 4. Okay, so you see the first line is about delta x, changing x. Delta y or changing y. Okay, let's see delta y for delta x. So here is 4 over 1. So it's just 4, right? So for this, from second pair to the third pair, again 2 to 3 is plus 1, that's plus 4. Again 4 over 1, 3 to 4 plus 1, 12 to 16 plus 4. So again 4 over 1. So they're always equal. They're always equal. Always 4 over 1, right? So therefore the relation is linear. Alright, okay, so all good. So let's move on to the next one. Okay, the next one, okay, let's see. From 1 to 3 is plus 2, plus 2. Okay, so let's see why. It's plus 4, plus 4. You see the pattern of it? Okay, so that's delta x, that's delta y, and we need to consider delta y for delta x as well. So you see that's 4 for 2, 4 for 2, 4 for 2. So of course all delta y for delta x are equal. So then the relation is linear. Is linear. Alright, so that will be the second one. Okay, for C, let's see. Okay, 1 to 3 plus 2, again, or plus 2, okay? 1 to 9 plus 8, 9 to 25 plus 16, 25 plus to 24 plus 24. Alright, so let's see this one. If we have delta x, delta y over delta x, so that will be 8 over 2, 16 over 2, 24 over 2. So 8 over 2 is 4, 16 over 2 is 8. Are they equal? No, they are not equal. They are not equal. Therefore, the relation is not linear, or non-linear, you might say. Alright, they are non-linear. Okay, good. Okay, so the last one, let's check. Right, plus 2, plus 2, plus 2. Okay, need to be boring, right? Plus 6, plus 6, plus 6. Alright, so you see this time, again, when we look for delta y over delta x, you got 6 over 2, 6 over 2, 6 over 2. Alright, are they all equal? Yes, they are all equals to 3. So the relation is linear. Alright, so basically we have 3 linear, 1 non-linear. Okay, so when you see delta y over delta x, the change in y over change in x is always the same number, constant, then they are linear, otherwise they are not. Alright, okay, let's move to a okay, and this is problem solving. Okay, why do we need to learn linear relation, not just direct proportion? So direct proportion is just one special type of linear relation in which the two variables are always in a constant rate or ratio, like what we have learned in the last lesson. But there are many situations in our daily life that they are not direct proportion, but they are linear. Okay, for example, for a telecom company offer the following monthly data plan. So if you use a mobile phone, possibly you need to have a monthly data plan, right? So from the plan, they will give you a basic service charge or a basic fee, about $20 per month. For this part of money, even though you don't download any data, you don't upload or download anything, they still charge you $20 as a basic service charge. And for every 1 gigabyte of data, so after that, extra 1 gigabyte, okay, they charge you $10. Alright, okay, so let's see how these plans work out for you. Okay, so we have two variables. F is the total monthly fee to be paid in dollars. This data, amount of data, okay, of course data in gigabyte. Alright, so for example, when D is 0, that means you do not use any data for that month. Then you still need to pay $20 as the basic charge. Okay, after if you use 1 gigabyte, how much do you need to pay? Okay, the calculation would be like this. That would be $20. Okay, and on top of that, you need to add $10 because that's one 1 gigabyte, and for each gigabyte you need to pay $10, right? So this one will be $20 plus $10 becomes $30. Okay, so it's a basic charge fee plus the data fee. The data fee is $10 this time. Okay, how about 2 gigabyte? And you will have $20 as the basic charge, and for each gigabyte you need to pay $10. So it will be 2 times $10 will be $40 this time. Okay, $40. Okay, and we use the same idea for 3 gigabytes. Okay, it just becomes $50. For 4, $60. Okay, do we see a linear relation here? Okay, we might have a try. Okay, we need to check whether this is the case. Alright, okay, from 0 to 1 plus 1, from 20 to 30 plus 10, right? And from 1 to 2 plus 1 again, from 30 to 40 plus 10 again, and from 2 to 3 plus 1 again, plus 10 again, and okay, plus 1 again, plus 10 again. Okay, so you see that the change in data and the change in the monthly feed actually they are in a constant ratio. So whenever you use 10 divided by 1, it's always 10, right? Okay, so that means the delta F over delta D, just like what we have done before, delta Y over delta X, is always a constant. So that means they are linear, but here we don't need you to check whether they are linear because we are going to graph it. You need to graph the relation. Okay, so to graph the relation, okay, so 0, 1, 2, 3, 4, right? So we need to draw an axis right here, which representing the independent variable, which is data. Okay, and you need to draw the vertical axis, which means the fee you need to pay. Right, so yes, alright, so let's see what happens, and need to have some points on it. Right, let's set this one's 1 gigabyte, 2 gigabyte, 3 gigabyte, 4 gigabytes. Right, for the amount of data, that's 20, and that okay, so look, oh sorry, it's not 200, right? Okay, got it wrong. It's 10, then that would be 20, that would be 30, that would be 40, that would be, alright, okay, 50, possibly 60. Alright, okay, so what are the points? When it's 0 is 20, okay, then when it's 1 becomes 30, when it's 2 becomes 40, 3 becomes 50, 4 becomes 60. Alright, okay, so let's draw the line. Okay, so that's how it looks like. Alright. Okay, so you see this of course is a linear relation because you see a straight line, but give two reasons whether this is a direct proportion. No. So let's answer it. This is not a direct proportion because the straight line does not pass through the origin, and the rate f over d is not a constant. We know that delta f over delta d is constant, but not f over d. Okay, you could see that from the table when you look for f over d. So for example, when this is 1 and 30, 30 over 1 is 30, but when for the next one it becomes 40, 40 over 2 is only 20. Okay, so there are two reasons whether to say that this is not a direct proportion, and of course it's still a linear, but it's not direct proportion. Okay, right, so we have another example. This one will be very similar to the last one. Basically the same idea is about the surface apartment. Okay, so for a surface apartment, they will have certain rental plan for long-term tenants. So if you live in a surface apartment for a very long time, for example, if you stay for 1 week, then the charge will be like in a package. So that would be basic accommodation surface charge for $400. Apply even it's not an overnight stay. So if you go to this surface apartment, you want to stay there for 5 hours only, then they still charge you $400, even though you don't stay overnight. For every overnight stay, they will charge you $100 per night. Okay, so you see that's the plan. It's a bit like the telecommunication plan for a mobile phone, for a data plan, right? Because it's just like, even though you don't use the service, they still charge you the even you not staying overnight, in this case they still charge you a basic charge fee. Just like when you use a mobile phone, even you don't use any data, they still charge you a basic fee for service. Alright, so let's see. There are two variables. One is total accommodation charge, the other is number of overnight stay. Okay, let's say number of nights stay is 0. So if there's no overnight stay, how much charge is it? And of course you are still going to pay the basic charge, which will be 400. Right, if you stay for 1 night, what will be the charge? With 400, on top of that you need to pay 100. Okay, so that would be 500. Okay, and for 2 night stay, okay, should be 400 again, but this time you stay 2 nights, so total will be 600. For 3 nights, 400 plus 300, so it should be 700. Okay, for 4 nights is 400 plus 400, 800. Okay, so let's see if this showing us a linear pattern, right? So plus 1, always plus 1, plus 1. Okay, plus 100, plus 100. Okay, sorry, I need to make my arrow a little bit in line. Plus 100. Okay, plus 100. Okay, plus 100. Okay, so you see the change in course over the change in light. So this is delta n. So if this is delta c, you see delta c over delta n is always 100 over 1. So it's always a constant. So that's why they're linear. Okay, you don't need to answer this as a proof to say that they're linear. I just show you from the table. Okay, the question doesn't ask you to use this method to show whether this is linear. And we are going to plot the graph, then you know they must be linear. Okay, right? So may I give you some time to plot the graph and answer the last question, because basically they're the same as the last one. Okay, and then you just pause the video now and then we come back to track. Okay, so you see basically just use the same method to plot the graph, and you need to label the two axes as well with the corresponding quantities and variables. Okay, so you must see a straight line. If the points you plot are not on the same straight line, then something wrong. There's something wrong. Okay, and for the last part, whether this is a direct proportion, of course no. Actually, we are going to use exactly the same argument here. So I'm just copy and paste, but of course I'm going to change the quantities here. It's no longer f over d, it's now c over n. Alright, okay, so that's basically the part of the how to see whether how you can see that's a linear relation. How could we plot the straight line from the table given? Okay, so these things are not the most difficult thing. I hope most of you could understand the difference between a direct proportion and a more generally linear relation. Okay, so the basic idea is direct proportion is one type of linear relation, but there are other type of linear relation which is not direct proportion. And if you want to check whether a relation is a linear or not, you need to use to see the change in x and change in y, and to see whether the change in y divided by change in x is a constant. Okay, to check whether a relation is a linear relation, you are not going to use double line method, although we look similar, but we use plus rather than multiplication. So you need to be a bit careful about this. Okay, so that's the part 1 of our lesson 4 video, because lesson 4 is quite long. So it will take 2 videos to finish this. Okay, so let's stop here.